The atomic nucleus is the central part of an atom, containing the vast majority of its mass and all of its positive charge. It was first discovered in 1911 by Ernest Rutherford through his famous gold foil experiment, which involved bombarding a thin sheet of gold with alpha particles and observing their deflection patterns. The atomic nucleus is composed of two types of particles, protons and neutrons, collectively known as nucleons. Protons are positively charged particles, while neutrons have no charge. The number of protons in the nucleus determines the atomic number of the element, while the total number of nucleons, protons and neutrons, determines the atomic mass. The forces that hold the nucleus together are known as nuclear forces, which are much stronger than the electromagnetic forces that govern the behavior of electrons in atoms. These forces are mediated by particles known as mesons, which are exchanged between nucleons and help to bind them together. Nuclear reactions, which involve changes in the composition of the atomic nucleus, are the basis of nuclear energy production and radioactive decay. In nuclear fission, heavy atomic nuclei such as uranium are split into smaller fragments, releasing energy in the process. In nuclear fusion, light atomic nuclei such as hydrogen are combined to form heavier nuclei, also releasing energy. The study of atomic nuclei is known as nuclear physics, which encompasses a wide range of research topics, from the properties of individual nucleons to the behavior of entire nuclei in complex systems. Nuclear physics has many applications in fields such as medicine, energy production, and national security, and continues to be an active area of research and discovery. The discovery of the atomic nucleus is credited to Ernest Rutherford, who conducted the famous gold foil experiment in 1911. In this experiment, Rutherford directed a beam of alpha particles at a thin gold foil and observed their deflection patterns. He found that most of the alpha particles passed through the foil with little or no deflection, but a small number of them were deflected at large angles or even bounced back. Rutherford concluded that the deflection of the alpha particles was due to the presence of a concentrated positive charge in the center of the atom, which he called the atomic nucleus. He proposed that the nucleus was composed of positively charged protons and neutral particles, which he called neutrons. The characteristics of the atomic nucleus include its size, mass, and charge. The nucleus is extremely small compared to the overall size of the atom, with a typical diameter of about 10⁻14 meters. However, it contains almost all of the mass of the atom, with the mass of each nucleon, proton or neutron, being approximately 1 atomic mass unit. The charge of the atomic nucleus is always positive, due to the presence of protons. The number of protons in the nucleus determines the atomic number of the element and its position on the periodic table. The total number of nucleons in the nucleus, including both protons and neutrons, determines the atomic mass of the element. The forces that hold the atomic nucleus together are known as nuclear forces, which are much stronger than the electromagnetic forces that govern the behavior of electrons in atoms. These forces are mediated by particles known as mesons, which are exchanged between nucleons and help to bind them together. The behavior of atomic nuclei is the subject of nuclear physics, which encompasses a wide range of research topics, from the properties of individual nucleons to the behavior of entire nuclei in complex systems. The study of atomic nuclei has many applications in fields such as medicine, energy production, and national security, and continues to be an active area of research and discovery. The study of atomic nuclei is the subject of nuclear physics, which is a branch of physics that deals with the properties and behavior of atomic nuclei and their constituent particles. Nuclear physics encompasses a wide range of research topics, including nuclear structure, nuclear reactions, nuclear astrophysics, and nuclear technology. One important role of nuclear physics is in the development of nuclear energy technologies. Nuclear reactors use controlled nuclear reactions to generate heat, which is then used to produce electricity. Nuclear energy is a significant source of electricity in many countries around the world, and nuclear physicists play a crucial role in ensuring the safe and efficient operation of nuclear power plants. Nuclear physics also has many applications in medicine. For example, nuclear medicine involves the use of radioactive isotopes to diagnose and treat medical conditions. Radioactive isotopes can be used as tracers to track the behavior of specific molecules in the body, and can also be used to target and destroy cancerous cells. In addition, nuclear physics plays an important role in the study of the origins of the universe. Nuclear reactions are responsible for the synthesis of elements in stars and supernovae, and the study of these reactions can provide insight into the processes that have shaped the evolution of the universe. Overall, the study of atomic nuclei is essential for understanding many fundamental processes in the physical world, from the behavior of subatomic particles to the structure and evolution of the universe. Nuclear physics has many important applications in fields such as energy, medicine, and astronomy, and continues to be an active area of research and discovery. There are several types of nuclear particles, including protons, positively charged particles found in the nucleus of atoms, which determine the atomic number of the element; neutrons, neutral particles found in the nucleus of atoms, which contribute to the atomic mass of the element; electrons, negatively charged particles that orbit the nucleus of atoms, which are responsible for the chemical properties of the element; alpha particles, consisting of 2 protons and 2 neutrons bound together, which are emitted during certain types of radioactive decay; beta particles, high-energy electrons or positrons emitted during radioactive decay; gamma rays, high-energy electromagnetic radiation emitted during radioactive decay; mesons, particles that mediate the strong nuclear force between nucleons in the nucleus; quarks, subatomic particles that make up protons and neutrons, and are themselves bound together by the strong nuclear force. These are some of the most common types of nuclear particles, but there are many others that have been discovered and studied in nuclear physics research.